Hello, good afternoon, everyone. A warm welcome to our webinar on how to use LiDAR for crowd analytics. So my name is Cynthia Britton and I will guide you through the next approximately 45 minutes. First up, a few technical notes. In case you can't see a control panel for the meeting at the moment, or if it should just disappear during the webinar, it is probably hidden behind a small white arrow on a red background in the upper right or left corner of your screen. Just click on it and there you will have the possibility to enter questions already during the webinar or raise your hand. This will be especially relevant at the end of the webinar when we will have the chance for a Q&A session. Please note that this webinar will be recorded and published afterwards. Our two panelists who are with me here today are Stefan Dragic, our Sales and Business Development Manager and Crowd Analytics Expert from Blickfeld, and Lukas Baldeschwieler, Head of Sales from our partner EvoCount. They will start by introducing themselves and the companies before Stefan moves on to giving you an overview of crowd analytics application areas and current projects. He will explain what is needed to set up such a project before doing a deep dive into a customer project at the North Sea. But before we start, I would like to know how many of you are already familiar with LiDAR technology. We prepared a short poll and I would kindly ask you to simply choose the answer that best describes your experience with LiDAR technology. Have you heard of LiDAR technology before? Have you experience in working with LiDARs, or are you not familiar with LiDAR technology so far? So I can see the answers going up, and I can see that most of you do already have experience in working with LiDAR technology. Thank you for voting, and knowing this, I will hand over to my colleague Stefan.
Thank you, Cynthia. Hello and welcome again, everybody, to our webinar. A couple of things to start off with. I would like to first let you know that even though our team has diligently prepared for this seminar, for this webinar, the possibility for a technical glitch here and there always persists. So should there be a technical glitch, I would apologize in advance for that. The other things maybe to point out would be that I am still getting over a bronchial infection that I had a few weeks ago, which left me with a pesky cough that has a tendency to come back when I speak quite a lot, which I'm going to do, of course, right now in this webinar. So for that reason, let me apologize in advance should that happen. With all that out of the way, let's get started. My name is Stefan Dragic. I am Business Development Manager here at Blickfeld, and I work with various customers and partners on realizing projects in the field of crowd analytics, people counting and people tracking. The focus for our presentation today is crowd analytics. So we will briefly touch on a couple of different projects to better illustrate the subject before we dive deeper into our joint project with our partner Lukas from EvoCount. So Lukas, before I give you a chance to introduce yourself, allow me to give the attendants a quick overview of our company Blickfeld. Blickfeld was founded 5 years ago with a goal to develop solutions that make LiDAR technology accessible to every industry that stands to profit from digitizing their business environments. Our current product portfolio follows two main tracks: industrial applications and automotive or mobility applications. With IoT, Blickfeld currently focuses on crowd analytics applications in areas such as transportation hubs, retail, analytics, events, tourism, and destination management. Additionally, we offer volume measurement solutions, for instance, in the recycling, agricultural, and mining industries, as well as security solutions for critical infrastructure. As Cynthia already mentioned earlier, we are joined today by our partner Lukas Baldeschwieler from EvoCount. And without further ado, I would like to give him a chance to introduce himself and his company. So Lukas, please go ahead.
Thanks for handing over. My name is Lukas Baldeschüler. I'm head of sales at EvoCount. But who is EvoCount actually? As a spin-off from the University of Kaiserslautern, our company EvoCount was founded in 2015 by our CEO, Tim Ethelblin. The company's founder combined their experience in the event industry with research results to create a product that makes everyday life much easier for the end user. We joined Real Communication Group in 2019 for the company's further development. But now the question arises, what does EvoCount actually do? Well, as our company suggests, we are specialists in counting. Before the pandemic, the focus was on people counting. But due to further development, we count now what counts for our customer, be it cars, bicycle, or people. We are not only concerned with the pure count value itself. No, our system is about evaluating and interpreting the count values and automating processes with the help of the system, be it at the event, in tourism, in traffic optimizations, in the venue area, or in public transport. Our systems are intelligent crowd management systems to optimize the customer's experience and customer security. Now I will hand over to Stefan Beck.
Thank you, Lukas, for your introduction. So, EvoCount and Blickfeld are currently working together on an exciting, high-profile and high-visibility crowd analytics project at the North Sea shore, involving multiple locations, some, as you see here in this picture, located in nature preserves, thus fully autonomous, while others are installed along boardwalks, parking lots, beaches, etc. All, in fact, are tracking people, cars, and in some instances, we even track camper vans. But before we delve deep into the specifics of this project, I think it might be useful to give you some insights into the concept of LiDAR for crowd analytics first. So let's have a quick look at some of the many different applications we are currently working on with our customers and partners. The retail industry is one area where we are working on several large outdoor shopping center and mall projects with our partner Sensalytics from Stuttgart, Germany. These applications are focused on producing retail-specific KPIs, such as overall passers-by potential, customers versus store turn-in rates, path analytics, and dwell times. Another important application area is transportation hubs. At the airports and train stations, we can observe large people movements or flows that require in-depth real-time analysis for process streamlining. In this space, we have already realized a couple of projects with our customer Fraport, one at the Frankfurt airport, the other at the Baltimore airport. Also of great interest are the events and trade show industries. Here, our sensors can deliver rich data for analysis of display effectiveness or even overall trade show booth success. Heat maps, for instance, are an effective visualization of which displays work well and which displays are less frequented by visitors. In short, Blickfeld LiDAR technology can deliver value from almost any application by transforming observed people movements and flows into rich crowd analytics actionable data. Here are some additional recent crowd analytics projects that show the breadth of applications possible. First off, the Hochfügen ski resort. As you can see in the picture, the operator of this small skiing area in Austria wanted to know how many visitors arrive at the ski resort by chartered bus. They first tried a camera-based system, but found out quickly that the actual counting with that system was A, cumbersome, and B, inaccurate. That's when they contacted us. And just with one sensor installed up and running in just a few hours, we were able to cover the area of interest where passengers were being dropped by the buses. Here's some actual footage from that scene on the left, where you can see the video feed. In the middle, you can see the actual corresponding point cloud. And on the right, you can see the active counting dashboard. I already briefly mentioned our Baltimore airport application, which we realized with our partner Sensalytics. Even though this installation is physically in an airport, it's actually a classic retail project looking for classic retail analytics and KPIs. The goal was to gather data at 4 store locations along the airport hallways leading from the passenger terminal to the flight gates in order to determine total potential of passers-by versus the turn-in rate to each store, and then versus the store conversion rates, which was made possible by a special point-of-sale system deployed by our partner Sensalytics and integrated into their retail data analytics platform. So now that we saw some project examples, let's have a quick look at what's needed to set them up. And it's actually surprisingly little. In order to go from an empty environment to outputting actionable data, you really need only 2 things. Hardware, LiDAR sensors that produce a 3D image of our environment, the so-called point cloud, and perception software, which analyzes the LiDAR data and can provide active counts of classified objects with timestamps and corresponding 3D coordinates. And that's it. It may be helpful at this point to briefly look at how LiDAR works, what a point cloud is, and how we extract that so-called actionable data. LiDAR stands for light detection and ranging. The way it works is laser pulses are sent out into a scene. These laser pulses are in turn reflected and by any objects in the scene and detected by the laser detection module in our sensor. Based on the time of flight principle, which calculates the differential time between when the laser pulse was sent out and when the reflection of an object was received back into the sensor, we can calculate the actual distance to that object. This process is repeated thousands of times per second, and while the laser pulse is deflected over the scene. The resulting 3D point cloud, made up of all the reflection points, is by definition an active measurement of the entire scene and its objects. So now that we know the principle of how we generate a point cloud, let's have a look at how we turn these point clouds into classified objects and ultimately into actionable data. First step is to detect objects in the point cloud. How do we do that? Well, first we separate static points belonging to the background, seen here in grayscale, by clustering moving points in the foreground marked in red. The red clusters, of course, in the foreground are 2 people moving through the scene. By the way, applying the same foreground background principle allows us also to perform what we call background subtraction, by which the size of the data stream coming out of our sensor can be reduced up to 90% in some instances. The next step after detecting and classifying objects is actively counting them. The way we accomplish that is by drawing counting zones or counting thresholds into the scene, which is, as you can see here, rather simple and quite straightforward. Once in place, people moving across these counting zones in the direction of the green arrows seen at the center of the zones will be counted as entries, while movement in the opposite direction will be counted as an exit. This is basically how we can go from bare scene to actionable data in just a couple of steps. Now that you know all about Blickfeld's LiDAR technology for crowd analytics, let's take a closer look at our joint project with our partner EvoCount at the German North Sea shore. During and because of the pandemic, destinations along the German North Sea have experienced a renaissance of German tourism. Visitor numbers to the historic localities, beaches, lighthouses, boardwalks increased dramatically in the past 2 years. So much so that the local tourism boards and associations began looking for a solution to monitor and redirect people flows and streams in an effort to even out visitor numbers between destinations and thus avoiding over-tourism in certain locations while others would remain underutilized. Our partner EvoCount devised and installed a complex system of sensors, software, and displays. It includes 68 Blickfeld Cube 1 LiDAR sensors installed at 9 different locations using our Blickfeld Percept software stack to identify and count visitors as well as cars. This project will soon grow to a total of 90 sensors installed at 15 different locations across the German North Sea shore. The customer specified a broad set of requirements that needed to be addressed. For one, these destinations are public spaces, therefore the sensor solution needed to be privacy law compliant. LiDAR data is anonymous by design, and our sensors do not collect any so-called personal identification information, or PII for short. All data collected is anonymous, thus ensuring privacy. The destinations and areas where data was to be collected are very large. Our broad field of view, coupled with the ability to fuse multiple sensors into one common point cloud in Blickfeld's Percept software, allows us to efficiently cover large areas with a relatively small amount of sensors. The project was also designed to collect data day as well as night, so the solution needed to be fully independent of lighting conditions. Being that LiDAR possesses an intrinsic light source, it functions completely independent of ambient lighting conditions. In the example here, you can see a nighttime camera image where it is practically impossible to recognize anything at all, while the corresponding point cloud next to it looks exactly the same way day or night. Furthermore, these are all outdoor seaside locations. They required sensors that are weatherproof and able to collect data come rain or shine, in fog and during snow showers. The laser-based LiDAR sensors are much more robust in data collection than pixel-based systems when it comes to adverse weather conditions. Some of the measuring points are actually located in nature preserves, as mentioned before, where no power, no internet connections are available, thereby necessitating fully autonomous or self-sustained deployment using solar, wind power and cellular data transmission. Using a sensor with low power consumption was thus also a key requirement. Finally, some of the measuring points had to use existing infrastructure. Blickfeld LiDAR sensors are uniquely flexible when it comes to mounting options. Just about any existing infrastructure can be used to mount our sensors to. Let's have a quick look at a point cloud recorded just last week on location at a very popular pedestrian crossing over a bridge in the town of Gritziel at the North Sea Shore project. As you can see, the people walking over the bridge are detected as such and are counted once they cross the counting zone or the threshold, that big blue box in the middle. On the right-hand side of the screen, you can see the actual counts. So that's it for my part of the presentation. And with that, I would like to hand over again to my colleague Lucas, who will explain in a little more detail how the counting data generated by our sensors is further aggregated in the EvoCounts analytics platform. Lucas, please go ahead.
Thanks for handing over. After we now know how to generate the count values, thanks to Stefan, I would like now to give you a step further with you and show you our options for utilizing the data. EvoEyes is a web app interface that can be accessed from any internet-enabled device. EvoEyes allows geographic monitoring of multiple areas using the map view you see now in the video below. With quick analysis, data can be directly evaluated immediately. If customers need to be informed or you need to analyze data, you can also do it in our system with the dashboard function. Here, views can be generated that can be played out via any playout channels, such as digital signage displays, for example, or for example, LED screens. For historical analysis, you can filter and break down the data in evaluation categories according to our wishes. EvoEyes is further characterized by the fact that it offers individual user right management. Further, also routing settings in EvoEyes can be used, for example, to notify guests when the fill level reaches, for example, 1000. So to sum up, EvoEyes is a platform to analyze the data you have collected. You can create diagrams to show the data, and also you can use EvoEyes as a platform to ease your life, because there are automated processes which you can set up in EvoEyes. So this is a quick overview about our product EvoEyes and how we manage the data we get from the Blickfeld cubes. And now I will hand over back to Cynthia.
A big thank you to Stefan and Lucas for these insights into LiDAR technology and how you can use it. So now we have a couple more minutes left and we will jump right into a Q&A session. So if you do have any questions now regarding LiDAR data, regarding using LiDAR for crowd analytics or whatever comes to your mind, just feel free to ask. So there is a question opportunity in the control panel of the webinar. So just type in any question you have and we will be glad to answer, or just raise your hand and we have the chance to unmute you and you can just talk to us. So whatever you want to know, feel free to ask. We are happy to help.
Maybe good to know also who the question is directed to, if it's to Lucas or if it's to me. Let's wait for a moment and see what questions might come up.
So I think there's a first question to Lucas. Can you evaluate the people density?
Yeah, of course you can. So every data we collect, we can also interpret it. So no matter if it's people density is no problem for our system. You can show it directly with the dashboard function, for example.
Thank you, Lucas. And here is another question. How fast is the response time?
So actually the system we installed in at the North Sea is in real time. So if the people go through the counting zone, you directly get the counting data displayed in our web platform EvoEyes.
Thank you, Lucas.
No
Are there any further questions? So just feel free to type them in or raise your hand if you want to talk to us. Stefan, there's another question to you. How do you handle occlusions in the scene?
That's actually a very good question. So in order to get accurate counts in a scene, you definitely want to make sure that any occlusions are omitted by calculating how many sensors for a particular screen would be needed if there are any potential occlusions. Occlusions being things like either outside trees, indoors could be columns, but it could also be people shadowing or occluding each other. If you're looking at an angle that is too narrow, too shallow, there is always the potential that one person could be shadowing another person. So what we do is we take a look at scenes, and this is part of the service that we also offer when we deploy our product, is to have our application engineers take a look at the scene in question and take a look at possible occlusions and then calculate the numbers of sensors needed. For as long as an object is in full view of a sensor, it's tracked and it's counted.
Thank you, Stefan. Lucas, another question to you. Are there any problems when people walk very close together?
So I think it's more a question that relates to Stefan, but yeah, our experience at the North Sea shows that the system is quite accurate, even if people walk next together or close next together, or if they walk with a distance between them. So yeah, the system is quite accurate so far.
So maybe let me jump in there as well onto the question, because in fact, it is really a function of software more than it is of the sensor itself. So the sensor sees what it sees. The interpretation of what it sees is directly related to the algorithms used to interpret the scene. So two people walking very close to each other is merely a function of designing an algorithm that can look at that and potentially correct that.
Thank you to the two of you. Oh, sorry. So another question, is there a website to see more information about EvoCount? I think so. Probably there is. We will send you more information afterwards, and maybe we can just send it into the chat room as well. The websites from EvoCount as well as Blickfeld. Of course, you can find more information there. So some LiDAR come with a 270-degree angle sensing degree. How about yours? I think that's another interesting question. Stefan, maybe you can answer that one.
So I think that the question goes towards the different types of sensors that are out there. So there is what we call rotational LiDARs out there that can see. There are spinning LiDARs that can see up to 360 degrees. Our particular LiDAR sensor has a different approach. It is a non-moving part LiDAR. It's a MEMS mirror-based LiDAR that sports a field of view that is 72 degrees by 30 degrees, 72 degrees horizontal by 30 degrees vertical, and sports a fully configurable, software configurable, not only field of view opening, but also configuration of the amount of scan lines used. So in short, our LiDAR can basically be adapted to the particular scene that it looks at rather than the other way around. It's very flexible.
Thank you, Stefan. One more question regarding the areas that the sensors can cover. How large are they?
That depends. So I would need actually a little bit more information in order to be able to determine an exact figure, because it depends on the height and the angle at which the sensor is installed. Like I said, the field of view is 72 degrees maximum by horizontally by 30 degrees vertically. So that in itself, depending on the distance to the target object, will result in a footprint that is calculable. In general, an area like, for instance, at the Frankfurt airport, where we cover with one sensor 400 or 500 square meters at a time is possible. Then again, one would have to keep in mind any possible shadowing, so calculation of how many sensors for a space would be necessary. I hope that makes sense. Yes.
For me, it does. Now you should also be able to find in the chat the links to the websites from EvoCount and Blickfeld, so there you can find more information, but you have a couple more minutes left to just take the chance and ask any questions you face right away to Stefan and Lukas. So is the quality of the 3D point cloud, no, pardon. Oh, I think here comes the whole question. So to what extent do atmospheric influences like fog, especially at the sea, affect the quality of the 3D point cloud and identification?
That's another very good question. So let me attempt to answer this by saying if the fog or the snow experience in a scene is such that you literally can't see the hand in front of your face, our LiDAR is also going to be challenged. It's quite simple and straightforward. However, tests at the University, I believe, of Ingolstadt have shown that in general, you can say that a LiDAR can see far beyond the human eye what a camera-based system, a pixel-based system would be able to make out in a scene. A LiDAR can see far beyond that. We're currently also undergoing testing. The North Sea project is delivering some very good insights into that because fog is a common occurrence up there, snow as well. But we're actually doing some specific testing on the effects of rain, on the effects of fog, and on the effects of snow with particular distances and particular reflectivity. We'll probably have some data on that soon.
Thank you, Stefan. And what power do you use for the laser beam?
It's 905 nanometers.
That was quick, thank you.
Please don't get too technical. I am but a salesman.
So there's one more question to Stefan. Thank you for the presentation, first of all. And the person was wondering, what is the frame rate of the LiDAR product?
The frame rate is actually adjustable. This is an important aspect of what I just said before. So the ability to configure the amount of scan lines as well as the field of view will result in an adjustable frame rate, meaning in an adjustable refresh rate of the screen. So if you want a very, very high resolution in the point cloud with lots of points, then you can increase the amount of scan lines and the field of view, which results in a slower refresh rate. If you wanted to have a fast refresh rate, let's say a LiDAR mounted on a vehicle or mounted on a drone, on a moving object with other moving objects in the scene, will require a faster refresh rate. So you can then adjust the scene once again, the LiDAR to the scene rather than the other way around. I hope that makes sense as well.
It does, it does. Are there any further questions? Feel free to ask. Until then, we have another question regarding the North Sea project in detail. How do you transmit the data in the remote locations? I think, Lukas, this question goes rather to you.
That's definitely a Lukas question.
Thanks for the question. It's also a good question. So yeah, if we have your destinations where we have no, for example, internet connection, Wi-Fi connections, we are using normally mobile data to transfer the data to our servers. We have a controller directly installed behind the sensors to analyze the data, and there are only the counting data transmitted over the mobile data to our server infrastructure. Sorry.
Thank you, Lukas. Are there any further questions? So we talked a lot about people counting. Is it possible to count also other objects like cars, for example?
Definitely. So in fact, and Lucas can tell you maybe a little bit more. The North Sea project, for instance, had a specific requirement also that we engaged in a development project with them together to not just count cars, vehicles in that case, but to actually determine camper vans from cars. The requirement there being that the commune wanted to know when camper vans would illegally park overnight in certain parking lots, if I remember correctly. Is that right, Lucas?
That's right, yeah. But not only cars and campers, we also have the needs of our customer that they want to know how many bicycles or motorcycles are on the street, on, for example, or bicycle ways, to know about the utilization on them. And we also got new requirements now, which says that we should count, for example, dogs. We had some very special requirements to count boats on a sea. So yeah, there are definitely different requirements to count objects, and we also we also can count different objects with Blickfeld together.
And just to classify and to make sure that it's not misunderstood, we're working on those other classifications. And there's actually, in industry applications, there's a whole horde of other objects that we're being asked to start classifying. I think the inquiries about classifying objects are coming at this point a little bit faster than we can even begin to develop them.
That's right, yeah, it is.
So thank you very much. I think that was the last question for the moment. So last chance if you still face any questions. Otherwise, I want to say again a really big thank you to Stefan and again also to Lucas. Thank you for being here with us today. Also a big thank you to everyone who joined our first webinar today. So if you face any further questions now, the upcoming days or weeks, feel free to contact us. Schedule a free consultation meeting if you need any further advice. If you can think of any use cases you could need a LiDAR application for, please feel free to contact us. You will receive an email after the webinar as well with the contact details. So feel free to contact us. And we are really happy that you were here with us. We hope you enjoyed the webinar, and we say thank you and goodbye.
Thank you, everybody. Bye-bye.
Bye.